Hi, everyone. I'm very, very excited to be here. It's my first OpenSSF day, so I'm excited. So thank you for having me. I hope that you're enjoying this amazing event and the great talks and amazing speakers. And I know it's a tough hour, 4:30, so I will try to wake you up a little bit, so hopefully I will succeed. So let's get things started and talk about the 5 open source security tools that all developers should know about. Before I'll dive in, I think that we need to do a quick introduction. So my name is Raz Probstein. I'm a solution engineer at Git. I've actually been a full stack engineer for many years. I come with a wide background in cybersecurity. And I've joined Git a little over a year ago as a full stack engineer. And after 8 months at this position, I've decided to mix things up a bit and become a solution engineer. I'm also studying for my bachelor's degree in biotechnology, which is another thing. I'm a big foodie. I like to travel, so the fact that we're in Bilbao is amazing for me. I want to tell you a bit about Git as well. So Git is an open DevSecOps orchestration platform. We're helping modern dev organizations own their application security without hurting the dev velocity. We're automating the best-of-breed open source tools, and we're integrating security into your entire life cycle. So code, infrastructure, CI/CD pipeline, runtime, literally with no effort. So this was the introduction. I think now we can really kick things off. And we'll start by looking at this example project. Now, just by looking at it, we see that we have usage in Python, we have Terraform, we have Docker files, we have multiple DB queries, and we have API endpoints. Now, all of those are extending our potential attack surface. This means that the developers must take responsibility for the code they're writing. Just like no developer would deploy an untested code without, making sure it doesn't have any breaking bugs. We can all hope they're doing it. The developers should also make sure that the code is secured before deploying it. So security really should be a concern to developers, because they're actually, the first line of defense when it comes to our systems. So today we'll talk about what are the 5 categories of tools that we should consider, and how to evaluate an open source tool and any tool for that matter. After we set this baseline, we'll dive into each of those categories. We'll do the evaluation and analyze the relevant tools. Of course, I'll share our recommendation of the tools based on our experience at Git, because we've evaluated, tested, and benchmarked so many open source tools across all of those categories. Then we will get into how to leverage those tools, because it's fine, you chose the tools, but then you need to do some heavy lifting, getting the developers to actually take action and implement the tools themselves. And for the grand finale, I will talk about how you can take it to the next level, because we all like to be the best at what we do. So, starting with our first topic. So we have 5 categories of tools that we should take under consideration when thinking about developers-related security. We have code scanners to protect our code and our data, such as SAST and secret detection. We need to have dependency checkers to cover our libraries, for example, so SCA. We need to have infrastructure as code scanning to validate our infrastructure configuration. And we need to have container scanning to protect our packaging. And finally, we need to have runtime security as well to ensure that we're covered and safe in runtime. So how do we evaluate any tool? So we need to have one set of key factors to measure by, no matter the category of the tool. So we thought those are the key factors, the most important ones to actually do the evaluation. Results quality, this reigns supreme for developers. It's got to be good, first and foremost. We don't want the developers to handle anything that is not accurate or irrelevant for them. So this thing, you might need to potentially think about it overall. Then you have the developer experience, huge speed, ergonomics in the CI, anything that the developers actually like. It needs to be able to customize by you, because I think the tools needs to be customizable in order to produce actual and truly meaningful results. Not so many tools actually allow you to configure them and change them, so this is something that you need to keep in mind. And lastly, maturity. Don't pass over the young and good stuff. This might even be better than the old and supported stuff. We'll just talk a little bit about each and every one of those factors. What do you actually need to do in order to evaluate, and what we need to think of. So starting from results quality, I want to share a story that a friend of mine told me that is related to kind of what are the false positives and what are the false negatives that we need to take care of. So he said that his security team felt like the tools they're using missed some secrets. Those secrets were actually an example placeholders. Now, if we look at it from the developer perspective, there aren't true positives, right? There aren't actual secrets. They're just a placeholder. But technically, and from the security team perspective, they are true positives, and it is a hard-coded credential, you may say. So this is what you need to play out of. We need to make sure that developers don't get annoyed fixing something that is not relevant to them, and also make sure that the security team is happy and everything is covered. Also, you need to validate the tools by running on your code. And why use real code, you may ask? All vendors adapt the rules and the performance on sample projects. So this means it's artificial. You need to use your code in order to actually validate the results. And I recommend you run multiple tools at once and just kind of understand what are the different things that they're catching. If you are using your code, make sure that you're using the same repo, the same branch, the same version, just to make sure that you have just a unified testing for all of them. From a developer experience perspective, the tool needs to be able to run anywhere that the developer works. In the terminal, in the IDE, in the CI, just make sure that you're allowing them all of the options. The tool must be fast and quicker than tests in the CI. I'm talking about like few seconds locally of running, and you never want to hurt the developer velocity. If you hurt it, you don't get any adoption, no matter how much time and money you spend on any tool. The results need to be either human readable or machine consumable. Developers don't want to work hard to understand what we ask for them, so you need to take this under consideration. And lastly, you need to be able to run the tool by yourself. We need to allow our developers to run it by themselves and not be dependent on the security team or anyone else for that matter. Maturity-wise, here we're not talking about who is the vendor of the tool. A big name does not mean more mature or more accurate. We need to look at the popularity of the tool. We need to look at the active contribution and the involvement around the open source tool. Customizability. I'm a big fan of providing the most flexibility. People have different needs. My security needs are not your security needs. And being able to tailor the security to your specific and unique needs, this is what we're looking for. This is what we want. That's why at JIT we're providing a generic yet opinionated framework to orchestrate the various tools, but we are also allowing the user to configure it to their specific needs. All right, I'm doing a quick check-in. I hope you're alive and then it's weird that you're talking while sleeping. So we talked about the different categories and the factor for our evaluation, and I hope this is making more sense now that we have the foundations and the basics, the different aspects of the tools, the areas that we need to cover. I hope that you have a better understanding now on why each of these evaluation factors are important when choosing a security tools for your developers, and you know how to actually do the evaluation. So let's start by going over the different categories, and for each of them we'll evaluate the tools and I'll share our recommendations. So we'll start with the first one, which is code scanners. Our mission when using code scanners is to identify vulnerabilities and security defects in the code when I'm writing the code. So we have some competitors on this match. We'll have 5 matches today in the battle, and this is the first one. A key thing to note here, many of these tools and other tools in general are point solution for a single language. This could be problematic, because if you have a lot of languages, you cannot scale and your security team won't be able to maintain all of the different tools by themselves, just for the code scanner part. So our recommendation is semgrep open source. Now let's evaluate it together. In terms of results quality, it has over 2,000 rules that include other rules from other tools to extend the coverage, like Gitleaks and GoSec. It has support for over 30 languages. This together enhances the efficacy of the tool. I want to share an example of semgrep open source secret detection using the rule set of Gitleaks. I'm going to share all of those examples during the other categories as well, just to show you what the output of the tool looks like so you'll know what to expect. So here is the prompt that we use in order to trigger that scan, and this is one of the results that it found. From a dev experience perspective, you can run semgrep open source literally anywhere, in the CLI as part of your CI/CD, in a Docker container, and in the IDE as well. Also, it's extremely fast. You don't need to do any compilation here. In terms of our ability to customize it, it's very extensible. It has many output formats, and it's super easy to write rules to semgrep open source, so you don't need a PhD to do that. Finally, maturity-wise, semgrep open source has a large community of active contributors, and it has many years of development around it. So now let's move on to dependency checkers. The mission here is to detect publicly disclosed vulnerabilities in the various components that we use. Again, a view of our contestants for this match. And our recommendation is OSV-Scanner. OSV-Scanner is a recent tool that is maintained by Google and supporting most of the package managers. And if we dive into the evaluation of it, in terms of results quality, it leverages the OSV DB, and it has supports for over 13 languages, which is insane. Developer experience perspective, it uses the OSV schema, and here as well, you can run it literally anywhere. When it comes to our ability to customize it, we can specify the scan to scan specific SBOM and log files, and we have multiple scanning options like recursive scanned, and we have the ability to do ignore, which is an amazing thing. And maturity-wise, it's definitely a growing community, and there is a rise in popularity. So let's take a look at an example of a recursive scan for OSV-Scanner. This is the prompt to trigger it, and this is how the results look like. All you have to do is just OSV-Scanner -- recursive and any directory you want to scan. Now, let's move on to infrastructure as code scanning. Our mission behind this scan is to detect security misconfiguration in our infrastructure as code and prevent it from getting to our cloud. So infrastructure as code is shifting left. So we need to make sure that our security is also shift left. Those are the competitors for this battle. We can see that semgrep is here as well. And our weapon of choice is KICS. Again, let's go over the evaluation. In terms of results quality, it has over 2,000 queries with support of 18 frameworks. This is a lot. All of the rules are covered by unit tests, so this improves the trust that we have in the detection of it. DevX perspective, it provides over 200 remediation recipes. Now, this is a huge bonus when it comes to developers. We all know that developers don't like to work hard and don't want to handle security. Guilty. But they must do that in the shift left era that we're in. So providing them with a fix this goes a long way for them. And again, you can run it anywhere. In terms of our ability to customize it, the queries are written in OPA, in OPA, and it has the ability to support new frameworks. So it's very open and configurable. Maturity-wise, growing popularity and a growing community of contributors. Us included, we're also a part of KICS contributors. So let's say I want to build an EBS volume in Terraform, for example. we can see that the encryption configuration is commented out here. So I'm a careless developer. Now, if I'm scanning this code using KICS, I get these results that says that the volume encryption is disabled, and you can see exactly the line that is causing this vulnerability and the exact reason for it. All right, I'm doing another check-in. How's everyone doing? I hope that you woke up. So we covered 3 out of the 5 categories, and I hope that you are awake and ready for the next one, which is container scanning. The mission for this one is to detect both vulnerabilities and misconfiguration in the container images. Our competitors for this match, we don't have much, but we have 3. And our winner is Trivi. Here are the results of the evaluation. In terms of efficacy, it supports container scanning, file system, Git repos, virtual machines, secrets, and infrastructure as code. You can generate an SBOM using it. Developer experience-wise, it's fast. You don't need any setup, and you don't need any additional libraries to run it. And of course, you can run it anywhere. Speaking of our ability to customize it, you can write and run your own detection logic, which is amazing for us. And you can use plugin to extend the CLI. Maturity-wise, it's very popular, and it has a large community of contributors. Here's an example of an output of a Docker image scanning using Trivi. This is the prompt that we use, and this is what to expect when looking at the Trivi results. And I'm moving on to our final category of the day, which is runtime scanning. The mission in runtime scanning is to detect vulnerabilities in our web applications and in our APIs while they're running. So this is DAST. Some of the contestants for our final match of the day, and we chose ZAP. ZAP is one of the most powerful open source pen testing tools out there. We have evaluated ZAP, and I'm happy to share the results today. In terms of the quality of the results, ZAP has a lot of features, and it detects the OWASP top 10 risks, which is a good thing for us because we want to make sure that we're covered on the top risks for our web application, and it has over 250 rules. From a DevX perspective, you can run it anywhere, and you also have a desktop app, which is a unique thing for an open source tool. And you have a headless mode to integrate it in the CI/CD, so you can trigger this scan on deployment as well. In terms of our ability to customize it, it has over 100 extensions that are available today in the ZAP marketplace, and you have plugins to extend the CLI. Maturity-wise, it's part of the GitHub Top 1000 project, so you know it's well maintained, and it has a huge community and high popularity. Also a bonus, it just made its way to the Linux Foundation, so you can trust the community. A quick example of the results of runtime scanning using ZAP. This is the prompt that we use, and this is how the result looked like. And here you can see that ZAP also provides some remediation guidelines, so as we said, this is very helpful for our developers. Now, if we want to sum up all of the matches and battles that we had today, those are our recommendations for code scanner, open source semgrep, for dependency checker, OSV-Scanner, for infrastructure as code scanner, KICS, for container scanning, use Trivi, and finally, for runtime misconfiguration, ZAP. So this was a lot, and now that we've kind of gone through over the recommendations, I want to just point out what we've covered and what we have left. So we talked about the 5 categories of the tools that we need to consider. We explained why and how to evaluate those tools, and we talked about each category and analyzed and evaluated our recommended tools. So let's talk a bit about how you can leverage those tools, right? Because we chose them. Now let's do the heavy lifting on getting the developers to actually do something. So I recommend that you involve your development team from day one, okay? And do this in baby steps. So start in a small scope and progress from there. Don't start strong, and make sure you're not blocking or interfering the development life cycle. Start by making it potential. For example, don't integrate it in the CI and then make it a required check right away. Integrate it, but don't block the PRs on it. Get constant feedback from your developers. Tune the tools, and then adjust the settings based on this feedback, and just after that, expand the rollout. Also, make sure you have success KPIs for your testing efforts, and then keep track of them. This will help you make a decision from a more clean and objective place. Now, as we said, we need to keep track of our KPIs to ensure proper decision making. Here are some crucial metrics that I recommend you take under consideration just to monitor your team, see how the dev organization is operating. So security detection rate, mean time to resolve, the exposure window, all three important metrics. The screens that you see here are screenshots from the JIT platform. We're helping to measure the most crucial and important metrics as well. It's important to state out some of the challenges that you may face integrating this huge amount of tools. So, scaling the rollout of a tool. If you have over 3 projects, things might get tricky because you might need to have like per repo, per project kind of configuration. You may have a hard time achieving consistent behavior across all tools because we just saw the different output formats and how the result look like in the different tooling. And you might need to do some work getting the developers familiar with all of the tools formats. Maintaining all of the tools and keeping them up to date with all the versions and upgrades, this might also be a pain point. You want to make sure that they're always up to date, but you don't have any breaking changes. You need to keep track of this as well. There is also a big challenge in handling the existing code vulnerability, what we call a backlog, versus preventing new vulnerabilities. So you need to find the right balance because you want the developer to prevent any new vulnerabilities and keep them in scope, but you also need help fixing everything that is already out there. So you don't want to put an extra pressure and an overload on the developers, so you need to find the right balance for that. And also, the remediations that are provided by the tools might be a hit or a miss, so we need to validate them before using them. Now, as I promised, for the grand finale, let's talk about taking it to the next level, because if you really want to take it to the next level, JIT can help you do that. We use it on ourselves, so we're speaking with experience. You can do everything that I just talked about, including handling those challenges in literally a click of a button. We codify security plans and we automate them. Our engine orchestrates prepackaged open source, commercial, and cloud native tools to cover your entire environment. We're providing you with a one-stop shop for your entire product security at the tip of your fingers, including, of course, the success KPIs that we've mentioned. JIT has a research team that do all of the evaluation, benchmarking, and constant maintenance of the tools for you. And our mission is to make the developers the first line of defense without them having to be security experts. We're treating them like first-class citizens, and we're helping them take responsibility for the code they're writing without hurting the dev velocity and without taking them out of scope. Literally, all you have to do is just click to activate the scan that you desire, and JIT will take care of the rest. Now, if this is interesting to you and you want to know more, please check out our website. This is the QR code. It will take you there, or just visit us at jit.io. I really appreciate the opportunity to talk with you guys today. I'll happily answer any questions you may have offline. I'll be here after this session, and please reach out to me. This is my email. This is my LinkedIn and X or Twitter, whatever you like to call it. So thank you, everybody, for your time.